So now from the formula, delta E equal to 1 over 4 pi epsilon 0 square to z square a to power 4 and m v square b square. This delta E, which is the energy transfer to the electron, so this comes out to be m by 2, and this is 2v now. Okay, so 2v square. So this comes out to be this much. So when you just solve it, then you get the answer for B minimum. So B minimum, which is here minimum in this case. So B minimum comes out to be 1 over 4 pi epsilon 0 and z e square by m v square. Clear? But there is a caveat. Okay, this caveat is that this m is now relativistic, so velocity correction is required. So if we consider the velocity correction, then a gamma factor should be added here. So gamma means 1 minus v square c square. Okay, so this is gamma. Now you got the B minimum, and now we need to know what is the B maximum. So if we consider that this heavily charged particle, when moving in the medium, makes frequent collisions. Okay, makes frequent collisions, and say if between any two consecutive collisions it travels the maximum distance b, and meanwhile its velocity is v, then this time period is almost b by v. Okay, with velocity v and having the mean distance b, the mean time period is almost tau is equal to b by v. And if the frequency of the collision is nu, so we write here 1 by nu. Okay, but remember here, this time now is relativistic, so a gamma factor should be added. So gamma factor should be added. So what we do here, we add a gamma factor here. Okay, so b by v. So this b will be maximum distance. Okay, maximum distance traveled by the that means the maximum distance between electron and heavy ion or heavy charged particles. So B max H gamma V by nu. Nu is the frequency. So when you substitute this into the formula, then you get minus dE by dx. Okay, that is the energy dissipated per unit distance equal to 1 by 4 pi epsilon 0 whole square and 4 pi z square e to power 4 by mv square. Okay, and what, and n is the number density of electrons per unit volume, and here B max and here B minimum and this is dB by B. Clear? dB by B. And when you solve it, then you get an answer 1 over 4 pi epsilon 0 whole square and 4 pi z2 power 2 e to power 4 and mv square. This doesn't look good. mv square and n log and gamma square mv cube by 2 by z, not 2 z e square and nu. Okay, so this is what we get. And now if you want to calculate the Ne value in terms of atoms or molecular density, then you can write N equal to rho is the molecular density or atomic density of the material, N0 is the Avogadro number, and Z is the atomic mass of the system, and A. This is a well known formula, and A is molar mass, or you can say atomic mass here, different cases. So with this substitution minus dE by dx comes out to be e square upon 4 pi epsilon 0 whole square and then 4 pi z square n 0 z rho mv square a and log gamma square mv cube z e square and nu. So this formula is called Bethe formula. Okay, and this is called classical formula as well. This is called classical formula. But here one more thing you can add. Okay, so you can express this in terms of the electron radius as well, and the correction done by Bloch is given like this. So when the quantum mechanical correction were done, so dE by dx now looks like 2 pi n0 means Avogadro number n0, and r, okay, r make it different, so let us say r square. R means here electron radius, classical electron radius, that comes out to be 2.81 Fermi, and mc square rho, okay, z by a and small z square by beta square, and inside bracket log 2m gamma square v square and w max by I square minus 2 beta square minus delta minus 2c by z. Clear? So this is what you got, and here let me explain the terms. So r means here the radius of electron, this classical radius, which has been already calculated in electromagnetism, and that comes out to 2.81 Fermi, and I is the mean excitation potential, okay, and gamma is the velocity correction factor, this delta is density correction, and C is shell correction, or W max is maximum energy transfer in a single collision. Okay, maximum energy transfer in single collision. So this formula is now known as Bethe-Bloch formula, and this is an estimate of how the energy dissipates when a heavy charged particle enters in a medium. Okay. Okay, so we stop here, and I hope you understood the thing and you are able to derive this. So basic formula is fine, but you need not to go for the block formula. It is not in your course, so you can avoid it. Thank you.